and this is my Physics 2211 Lab 4 about oscillations. So the goal of this lab is to perform a tracker analysis on oscillating motion and create a glow script model based on this motion before comparing the two in terms of their x and y positions, and also finding the change in energy over time for the glow script model. We assume this is a closed system, meaning there's no net change in energy, and overall we found that the energy change system was 0, as assumed above. The x position for the model and the tracker analysis were almost identical, and then the y position for both differed, but they differed exactly opposite one another, and this was due mainly to a coding issue, not necessarily them being truly different from one another. First, we need to look at kinematics, including Newton's second law of motion and the position and velocity update formulas. We're given initial position, velocity, and time for the position update formula, or initial velocity, acceleration, and time for the velocity update formula. We also need to look at forces, an example being force of gravity being mass of the object times acceleration due to gravity on Earth's surface, and the spring force being equal to negative times the spring constant times s, which is the distance between the stretched length of the spring and the equilibrium length, times L hat, or the direction in which it acts. Finally, we need to look at energy. Normally, energy is the sum of work done by the surroundings on the system and heat exchange, but in this case, the change in energy of the system is equal to the gravitational potential energy, or negative mass of the object times acceleration due to gravity times height. Kinetic energy, which is 1/2 times mass times velocity squared, and spring potential energy, which is 1/2 times spring constant times s squared. Here's a relatively simple force diagram. On the left, you just see the object and the spring, and on the right, you see the two forces acting on it, including the spring force and the force of gravity. And here you can see the oscillation video, and watch as it moves back and forth and its pattern of motion changes, which seems to start almost kind of vertically, and then it moves sideways and then going back to vertically. Here you can see the tracker analysis of oscillation. And as you can see here, the two graphs, top and bottom, represent the x and y positions over time, clearly representing oscillation. Here you can watch it move back and forth with the center of mass tracking it, and it seems to slow down and speed up as it reaches each side. Here you can see the two graphs I previously mentioned. The video frames per second was 10.53, and there were a total of 100 frames. The object's mass was 0.402 kilograms. Time range was about 9.5 seconds. Initial position is given there, and the initial velocity was 0 as it started from rest. Here I set the system properties and initial conditions with the ball mass and initial position velocity. And I also added interactions with the spring constant and relaxed length of the spring being given by the video included with the lab instructions. And there you can see I defined kinetic energy, gravitational potential energy, and spring potential energy. Here you can see the calculation loop where I recalculated force of the spring, force of gravity, and the total force, and then updated the velocity and position according to the position and velocity update formulas before updating it and the energies as well. And this resulted in a model that looked like this. Obviously it's sped up, but you can see how it oscillated back and forth similarly in the video. And here you can see the graphs. Now, as seen previously here, the x position over time models were almost identical, with deviation at the end due to like external forces like air resistance, but the y position and time varied significantly but they were likely due to an error encoding because they were exactly opposite of one another as in mirror images. And the change in energy, as you can see below, the net energy did not change, and the others had an oscillatory pattern regarding them. And the potential sources of error include air resistance, loss energy, heat, non-ideal spring, all which have contributed to the kind of gradation and separation between the model experiment for x position, and then the human error and tracker analysis, as in placing the center of mass, could have also altered these results. Finally, what does it mean? We look at the energy principle. It was satisfied because the net change in energy was 0. as energy cannot be created or destroyed. And based on the two graphs, the average period of oscillation was about 1.45 seconds, and they both kind of supported that. And that period of oscillation determines not only the spring constant, but the spring force itself.